Okay, so today we talked about this problem, and it actually turned out more complicated than I thought. So I thought that it deserved a video on its own. And so here's a scenario. Pretend we roll two dice, and let's just say that one of them is white and one of them is black. So we can discern between them. And there's six-sided dice. My question is, how many ways are there where there's exactly one even die? And there's actually multiple layers to this. So at first glance, this seems like a this or that type of counting problem, in that either the white die is even or the black die is even. If you remember from the previous video, that if I'm trying to count how many ways to do this or that, it's the number of ways to do this plus the number of ways to do that, and then I need to subtract any possible overlap. And so this is what you would probably think to do is that, well, how many ways are there to count for the white die to come up even? That would be the first part. So I'll highlight that in yellow. I'll circle that in yellow. That'd be the first one. How many ways where the black die is even? That'd be that part. And then we need to take away the overlap. Well, how many ways is there for the white die to come even? At first glance, you might think there's three, but you have to think about, because yes, the white die could come up 2, 4, or 6. But don't forget that you're still rolling two dice. And so for every even die, or even result that the white die comes up, there's 6 possibilities for the black one. So for example, you can see it right here, that if the white die comes up as a 2, that black die could come up 1, or it could do 2, 3, 4, 5, or 6. So, and likewise, if I roll a 4 on the white die, it'd be 1, 2, 3, 4, 5, or 6 on the black die. And again for the 6. So yes, there are only 3 even results on the white die, but I have to consider the entire experiment. For each of those 3 results on the white die, there are 6 more results for the black one. And also vice versa, for the black die being even and the white one being whatever. Because for this particular instance, I don't care what the other die is. I just care that the white die is even in that part and that the black die is even in that second part. So this is again 3 times 6, and you can see those outcomes right here, highlighted in orange. So let's write this out. So the number of ways to do quote unquote this, which is the white die coming up even, is there's 18 of those. Likewise, there's 18 ways for the black die to come up even, which should make sense that they're the same because they're the same die. And then I need to subtract, if again, based on what we have been doing, I need to subtract the number of ways that there is a white die and a black die. And this one's kind of funky because this scenario now is that you look at those two outcomes differently or separately. So how many ways could the white die come up even? Well, that would be 3 ways, 2, 5, 6. So again, that would be 3 ways. And then the black die coming up even is also times 3, right? So right here, this is just the number of ways, oops, the white die comes up even, and that's the way the black one comes up even. Right? And again, you can see those 9 outcomes here in, I'll circle them in purple. There's one right there, 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 right? And which makes sense because you can see this is again where they overlap. And if I run this calculation, I'll have 18 plus 18 minus 9, which will leave us with 27. Here's the reason that this does not work. We are looking for how many ways can we get exactly one of the dice to come up even. What happened when we did this calculation and counted it as such? Well, look, if you count the yellow rows, well, there's 18 there, and you count the orange columns, there's 18 there. Where they overlap is where they are both even. So again, this overlap here, and purple, oops, and purple equals both even. When we subtract the 9, what are we doing is that we are accounting for that one by taking it away. But how many times has it been counted? It's actually been counted twice because again, once for the orange column and once for the yellow row, we actually want to count them 0 times. And so I need to take that away twice. And so the actual answer to this problem should be, because again, I want to take it away twice because this should not be counted at all. So the actual correct answer should be, and we're going to kind of scratch this off here, should be the same as before with 18 plus 18, but I'm going to take away 2 times 9 because again, it was double counted, sorry, where they were both even, those results were double counted, again, counted twice, but how many times should they actually be counted? They should be counted 0 times, so I need to take all of them away, leaving me with 18 plus 18 minus 18, which will leave you just with 18. And again, you can count those answers. Okay, so what went wrong here in terms of our calculation? It was this fact right here. That is exactly one of them. What we did here, and let's clean this up a little bit. What we did here, square box off in blue, and that is something. The calculation that we just that is how many ways I'll just say can a die come up even? So what's the difference between this is that we don't care if it's exactly one die. This is really saying at least one die comes up even. And so we would want to count those purple entries where they are boxed off, but we only want to count them one time. So since they are counted twice, we would need to subtract just, again, one of the countings. But since in this previous example, in the actual problem, we want only one of the dice to be even, I need to get rid of all of the accounts where both dice come up even. Okay, so if that's the case, then how could I actually do this kind of from the beginning without having to kind of really think about this? Well, one, you still have to pay really close attention to this exactly one piece. Okay, so I'm going to erase this now and start over fresh with another way to look at this. So since we want only one die to be even, we can actually we could fine tune exactly what we're looking for in the terminology. And here's what I mean by that. Instead of just saying exactly one way, another way to think about that, or sorry, exactly one dice to be even, is that the white die is even and the black die is odd. That would be like that would be the one scenario. The other option that we would want to count, again, the or part, is where the white die is odd and the black die is even. And so this is getting a little bit into kind of how to say some of the properties of like this probability thing, because you kind of see here that there's parentheses within parentheses. So if I was doing this, I would do the number of ways. So I'm going to shortcut this, call this event number 1 and event number 2. If I'm doing this now again, this is a number of ways to do this or that, 1 or 2. The number of ways to count 1 or 2, like we said before, is number of ways to do thing 1 plus number of ways to do thing 2 minus the overlap, if there is any though, minus the overlap of 1 and 2. Now, let's think about this. Is there any way that when you roll 2 dice, again, the white and black die, for the white die to be even, the black one odd, and at the same time the white one odd and the black one even? No, in this case, because the white die is only even or odd. It can't be both. It couldn't possibly be both. And so this is already 0. And so in a sense, we don't have to worry about that. Okay, so let's actually figure out then, though, what the number of ways for event number 1 to happen, because that itself is a compound event. There's two things happening. That on its own is an AND scenario. So how many ways are there where the white die is even and the black die is odd? So this one is actually not too bad, because how many ways could the white die be even? And then this is a scenario where you would look at them again separately. So again, how could the white die come up even? Well, there's three ways. There's 2, 4, 6. So there's three ways. Oops. How many ways could the black die come up odd? There's also three ways, 1, 3, 5. And then we would multiply them because it's and. And that right there is the number of ways to do that thing number 1 we said above. Plus the other way, which is number of ways to get an odd result on the white die and a even result on the black die, is pretty much the same thing, because the odd die is going to be 3 again, 1, 3, 5, and then 3 again, 2, 4, 6. And that's the number of ways to do thing number 2. And right here you'll see it's going to be 9 plus 9, which is 18, just like there was before. So hopefully that makes things a little bit more clear. This is definitely like a spicy problem on its own. Just it looks relatively simple, but you can kind of see where you could get lost. And so hopefully this video explained the difference between exactly one and if that exactly one was not there in the problem.
I just want to clarify what I mean by count this part separately right here, because I was just reviewing this and I realized that, wait, why do you do that? Thing about this is that when, again, we are rolling 2 dice. And so what's happening here is that you are rolling. So let's actually just talk about how the quote unquote experiment goes. That you roll 2 dice, a white and a black die. And so when I'm looking for the number of ways that the white die comes up even and the black die comes up odd, what's really going on is, well, I could roll them this at the same time, or I could roll them one and then the other. It really doesn't matter, because you imagine, like, in reality those are the same thing, really. And so what's going on is that, what's the probability of rolling the white die comes up even and then the black die comes up odd? And as I write this, I realize I'm kind of writing the same thing that I just said, but how many ways are there to roll the white die even has nothing, absolutely nothing, to do with the black die. And so there are 3 possibilities for the white die to come up even. And then when you roll the black die, there are 3 ways that comes up odd. And that's why you just have to multiply the 3 times 3. In the previous example, I had this written up. I think this came up from class. Why is it 18 right here, circled in yellow right here? Or sorry, circled in yellow. Why is it 18? Is because we are counting how many ways are just how many ways does the white die come up even, or the black die come up even. And so in that case, we are counting the outcomes that actually come about when the white die comes up even. And so how many are there? Well, again, the white die can come up 2, 4, or 6, as evidenced down here. And the black die is what it is. It's 1 through 6, 1 through 6, 1 through 6, and that's why there's 18. But in this scenario over here, we are just looking at how many ways do you roll first the white die even, and then, again, I kind of saying that as if that's going to help emphasize things, and I hope it is, and let me know if it doesn't. And then the black die comes up odd if you count them as, you literally roll 1 die and then follow it up with the second die. So hopefully that makes a little bit more sense if you were confused about why that's just 3 times 3.